Before we define the concept of a vector, let's start with the concept of a scalar. Scalar is just a number, one single number. So 1 is a scalar, -3 is a scalar, 3.141 is a scalar. A scalar is just one quantity which is referred to as a number, any number. Integer, complex number, real number, just a number. A vector, however, has two properties. Magnitude and a direction. Graphically, we use an arrow to represent a vector. And an arrow has a starting point and an ending point. And the ending point will be represented by the tip of my arrow. If I want to write this vector mathematically, and I want to call it vector A, I would write A, and to differentiate this letter A from the scalar A, I will put a little arrow on the top. This is reminding me that I'm dealing with a vector A, not a scalar A. So let's define this vector going from this position to this position as my vector A. The next thing about vector is, as long as you don't change neither of those two properties, it's always the same vector. Therefore, if I take my vector A and I move it around, this is still my vector A, because I haven't changed neither its magnitude nor its direction. So obviously the magnitude of the vector is represented by the length, how big it is. This example, vector A has this particular length from here to here. This would be a shorter vector. In this case, I have only changed the magnitude. I haven't changed the direction between this vector A and this vector B, but I have changed its length, therefore I have changed its magnitude. Similarly, I can stick with the same magnitude, but I can just change its direction. This would be a different vector. Let's call it C. Because even though it has the same length as vector A, its direction is different. It points in a different direction. So if I have, say, vector A, which again starts here and ends here, and I would like to compare this vector to another vector which has the exact same length but opposite direction. If he has the exact same length, then this length should be the same as this length. If I would like to flip his direction, instead of going from here to there, I want the vector to go from this position to this position. Therefore, I'm going to flip it and put my arrow on the other side. So, this is my vector A, and this must be a different vector because even though they share the same magnitude, they have opposite direction. Since the direction of this vector is related to the direction of this vector by just an angle of pi, or just 180 degrees, mathematically we can represent this vector as minus A. So if you have a vector pointing in a particular direction and you flip the direction of this vector, whoa, no, it's not going to work. If you have a vector B going in this direction and you flip its direction by an angle of 180 degrees such that its length is conserved but its direction is flipped, this would become minus B. Vice versa, if you have a vector C in this direction, this would be minus C. So the relationship between C and minus C is that they share the same magnitude, they have the same length, but they have opposite direction. and the relationship between their respective direction is an angle of 180 degrees.